answers to the questions on the cases strategy sheet. Question number 1 is about some people telling lies or telling the truth. Because this is an example of the cases strategy, I'm basically saying that there's, when you look at the question, there's only 5 possible answers, because the question is how many of them were telling the truth. So it's either none were telling the truth, 1 were telling the truth, 2 were telling the truth, 3 were telling the truth, 4 were telling the truth, or 5 were telling the truth. And what we do is we basically eliminate those possibilities. Now, under each of those cases, let's just work out who was right. Pierre says just one of us is telling the truth. If nobody's telling the truth, he's wrong. If one person's telling the truth, he's right, etc., etc. What about Kadir? He says what Pierre says is not true. So all of these, what I'm now going to do is going to be the reverse of those. So in other words, in the case where 5 people are telling the truth, then Pierre is wrong because he says just one person is telling the truth. And in the case where 5 people are telling the truth, Kadir is correct because he's saying that Pierre is wrong, which he is, in the case where 5 people are telling the truth. Now, of course, it depends upon how many people are telling the truth, but that's the genius of this strategy. If there are only 6 possibilities, just work through them. I'm going to keep going. Ratner, what Kadir says is not true. So wherever Kadir was right, Ratner will be wrong, and wherever Kadir was wrong, Ratner will be right. Then Tanya says, then Sven says what Ratner says is not true. So we'll do this switch again. And then finally there was Tanya, who says that what Sven said was not true. Now the whole point of this, if it's going to work, is that you have to have some basis for eliminating the possibilities. And basically what we do is we just count up the number of truth tellers in each case. So that's 2, 3, I'm just counting the ticks. And the only case where the number of truth tellers matches the actual case heading is this one. So that must be the number of people telling the truth. All the other cases are self-contradictory. Started out in this column with 5 people telling the truth, but when we count the ticks, it's only 2. So that is a non-existent case. It's only a case in theory. So anyway, that's the answer. The answer is there must be 2 truth tellers because that's the only case that works. Question number 2. 3 consecutive digits. Oh, sorry, the consecutive digits 1, 2, 3, 4, so 4 consecutive digits, can be arranged to make a correct division in that order, because 12 divided by 3 equals 4. And the question tells us that one other sequence of 4 consecutive digits makes a correct division just like that. And they want to know what the answer would be. Well, there's only so many ways you can write digits in order. Here they are. Here's the whole point of the strategy, is that it's great for when there's only so many things that it could be. That's literally all it can be. There's no other way to have a run of 4 consecutive digits. That's not quite true. You could have 7, 8, 9. But that wouldn't be consecutive. I guess you could have 0, 1, 2, 3. Now you just work through them. Which one works? What's that one? 56 divided by 7 equals 8. So the question wants to know what that last digit would be. So the answer is 8. Okay. Now question number 3. This is an example of how we're going to muck around with a diagram. But because there's only so many ways that you can muck around with dominoes, we're going to get the answer pretty quickly. So we've got a 1-2 domino, we've got a 1-5 domino, we've got a 2-5 domino, we've got a 4-5 domino, we've got a 4-6 domino. What I'm doing here is an example of expressing the problem in my own words, just to make sure that I'm reading it accurately. I mean, I'm not making that much of a change, I'm just turning dots into numerals, whatever works best for my brain. Now, this person in the question wants to arrange them in a circle so that the pips match in classic domino style. So, for example, you could have this situation. To kick off with, the one matching the one. Okay, so if we're going to arrange these in a ring, the question is how many definitely can't be placed next to the 1-5 domino, and there's only a couple of possibilities for this because there's only 5 dominoes. So maybe the answer is none. So maybe any of them can go next to that. Maybe the answer is 1. Maybe there's just 1 domino that can't go next to that. Maybe the answer is 2. Maybe there are 2 dominoes that can't go next to that one. What about, it could be 3. Maybe there are 3 dominoes that can't go next to that one. Now, I don't think the answer can be 4. That's ridiculous, because no matter what happens, there's going to be 2 dominoes next to it. So, for example, we've already got 2 dominoes next to it. So it's either 0, 1, 2, or 3. So that's why I can use the cases strategy. Okay, well, I'm just going to see if any of those cases work better than any others. Okay, so let's see if we can make these work. Okay, so can I do can I make these work? Okay, so I could go 1, 5, 5, 2, 2, 1, then I ran out of options. So, yeah, I think I'm pretty sure I'm run out of room here. So 5, 2 can't go next to 1, 5 because you just ran out of options. Okay, let's try. So 5, 2 gets the chop. Okay, can I put 1, 2 next to it? 1, 2, 2, 5, 5, 6, 6, 4, 4, 5. So it's worked. So 2, 1, so the 2 and the 1 domino is definitely possible. Okay. Now that one's irrelevant because that's the domino that we start with. Okay, let's try 1. What else can I start with? Oh, I can start with this one. 5, 4, 4, 6, 6, 5. But now I've run out of options. Oh no, I haven't. I can go 5, 2. Yeah, and I can go 2, 1. So 5, 4 is a sweet possibility to put next to it. Now you can't put 4, 6 next to it because it doesn't. Neither the 6 doesn't match either end. The 4 doesn't match either end. So that definitely can't work. 5, 6 we'll need to investigate. Okay, so can I do a 5, 6? Here we go. 1, 5, 5, 6. 6, 4. 4, 5. I think I've run out of options, but I don't think I have. So 1, 5, 5, 6. Oh, here we go. 5, 2, 2, 1. So in other words, 5, 6 is possible. So therefore, there are 2 that you can't put next to it, and that's the answer to that.